All right, section 2.6 is talking about properties of equality and congruence. So we're going to look at three main ones. The first main one is the reflexive property. This means that Voltron is the same height as Voltron. So yes, these are transformers. It means that the same thing is equal or congruent to the same thing. So for example, we have the reflexive property of equality saying that AB is equal to AB. This is talking about the length. So the length of AB equals the length of AB, or the measure of angle A equals the measure of angle A. So we're talking about the measures and it equals itself. Property of congruence is talking about the actual segment or the actual angle being congruent to itself. So think of reflexive property as looking in a mirror and you see a reflection and you see the same thing. The next property is a symmetric property, and this has to do with the order. So if Voltron is the same height as Megatron, then Megatron is the same height as Voltron. So it doesn't matter what order you say something is equal or congruent. For example, 1 plus 1 equals 2 and 2 equals 1 plus 1. It doesn't matter which order because they're equal. So if AB equals CD, then CD equals AB. The order doesn't matter. Again, equality, we have an equal sign. We're talking about the actual length or the actual measure, whereas congruence has a congruent sign. We're actually talking about the segment or the angle. So symmetric property has to do with the order. Transitive property is similar to the law of syllogism in section 2.5. So if Voltron is the same height as Megatron and Megatron is the same height as Optimus Prime, then we know that Voltron is the same height as Optimus Prime. So it's kind of like the law of syllogism where we get rid of that middle man or the one that's repeated, and we can say that Voltron is the same height as Optimus Prime. So again, same thing with equality and congruence. So we get rid of that middle man, CD, and we can say that EB equals EF. So which properties? Segment GH is congruent to segment JK, then segment JK is congruent to segment GH. That is the order, so that's the symmetric property of congruence because there's a congruent sign. D equals DE, it's equal to itself, so that's the reflexive property. You can kind of picture looking in a mirror, you're going to see the same thing back. And then the last one, if angle P is congruent to angle Q and angle Q is congruent to angle R, then we know angle P is congruent to angle R. So we get rid of that middle man, angle Q, and we can say that angle P is congruent to angle R. So that is the transitive property of congruence, since we have a congruent sign. So in the diagram, N is the midpoint of segment MP. So that means that this half MN is congruent to this half NP, because if N is the midpoint, it's the middle. So we can say that MN equals NP by definition of midpoint. Then they tell me that P is the midpoint of segment NQ. So that means that NP is congruent to this half PQ because P is right in the middle. So NP equals the length of PQ. Again, same thing by definition of midpoint. So last but not least, we are trying to conclude that MN equals PQ. So we want to show that MN equals PQ. And if you can see here, we have NP as that middleman. So we can get rid of it. They're both equal to NP. So we can get rid of it and say that MN equals PQ by the transitive property of equality, since there's an equal sign there, since we were talking about the lengths. Angle 1 and angle 2 are vertical angles, and angle 2 and angle 3 are congruent. Show that angle 1 is congruent to angle 3. So angle 1 is congruent to angle 2 is which theorem? Well, they told me that they were vertical angles, so we know that they're congruent by the vertical angles theorem. Okay, by definition, vertical angles are congruent. Then they gave me angle 2 is congruent to angle 3. So that just says given. And last but not least, we're trying to prove that angle 1 is congruent to angle 3. So again, we have that middleman angle 2. We cross it out. If they're both congruent to angle 2, then we know that they have to be congruent to each other. And that is by the transitive property of congruence. Oh, they already have that part there. Transitive property of congruence. In the diagram, segment AB is congruent to segment FG, so let me mark that. AB is congruent to FG, and BF bisects segment AC and segment DG. So let me mark that. So that means that this half is congruent to this half, and then ray BF, well, actually line BF bisects segment DG as well. So that means that this half of DG is equal or congruent to this half of DG. So how did we know that BC was congruent to AB? Well, they told me that BF bisected segment AC. So this is definition of segment bisector. And what was our segment bisector? Our segment bisector was line BF. And then we know that segment AB is congruent to segment FG. So we knew that AB is congruent to segment FG. And how did we know that? They gave that to me up here. So that's a given. Then segment FG is congruent to segment DF, and we knew that one again because of the segment bisector. Okay. Line BF was the segment bisector, and it bisected segment DG, so it cut it in half. So that's how we knew the two halves were equal. And then last but not least, so if you look, we're trying to say that segment BC is congruent to segment DF. We have the transitive property again twice. So this is the transitive property of congruence. So you guys see we are canceling out that middleman, and we have segment BC is congruent to segment DF. Then we have a bunch of properties of equality. So addition property of equality. This is when if you do something to one side of the equation, you have to do it to the other to produce an equivalent equation. So here, addition property, we're adding 20 to both sides. Here, subtraction property, we're subtracting 5 from both sides. Multiplication property of equality, we're multiplying both sides by 4. Division property of equality, we're dividing both sides by 8. And the last one is a substitution property. If they say that x equals 7, instead of writing an x here, we're going to replace that and substitute it with a 7 instead, because we know that x equals 7. They're the same thing. So if measure of angle 2 equals measure of angle 3, then measure of angle 3 equals measure of angle 2. Let me bring up these properties here. Okay, so in this one, this has to do with the order, right? It doesn't matter whether I say angle 2 or angle 3 first. So this one is the symmetric property of equality. Next we have measure of angle S is 45 degrees, then the measure of angle S plus 35 equals 80 degrees. So what they did is they added 35 here, and then they added 35 here, and that's where they got the 80 from. So that's the addition property of equality because they added the same thing to both sides. AE equals EG, and EG equals JK. Then we know that AE equals JK. So they cut out the middleman EG here, and they got that AE equals JK by the transitive property of equality. If measure of angle K equals 9 degrees, then 3 times the measure of angle K equals 27 degrees. So they multiplied both sides by 3, so that would be the multiplication property of equality. If AB equals 12, then 2 times AB plus 3 equals 2 times 12 plus 3. So you can notice here they had an AB, now they have a 12. That's because AB equals 12, so they substituted 12 in for AB. Angle 1 and angle 2 are both supplementary to angle 3. So that's why in this first step it says measure of angle 1 plus measure of angle 3 equals 180, because they said angle 1 is supplementary to angle 3. So how did we know they added to 180? Well, that's what it means to be supplementary. So this is definition of supplementary angles. And it's the same thing for the next step. They told me that angle 2 is supplementary to angle 3, which means that by definition of supplementary angles, we know that they add up to 180 degrees. Okay, this next step, you can see if you look at the previous steps, we're saying that these two are equal. So measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. Now, you might be tempted to think that that's transitive property, but it's not transitive property. It's actually substitution. So since they're both equal to 180, we can actually set them equal to each other. So this is substitution property of equality. And then how did they go from the third step to the fourth step? They subtracted the measure of angle 3 from both sides. So that was 0 and that was 0. And they were left with the measure of angle 1 equals the measure of angle 2. So this is the subtraction property of equality. And last but not least, how do we know if the measure of angle 1 equals the measure of angle 2? How can we see that angle 1 is congruent to angle 2? That's by definition of congruent angles. So that's what it means to be congruent, is that their measures are the same. So the fourth step told us that their measures were the same, therefore we can say that the angles are congruent by definition. And the last one, M is the midpoint of segment AB, which means that segment AM is equal to segment MB. So that's what they have written in this first line, and that is by the definition of midpoint. We know that one half is equal to the other half. The next step, the whole segment AB equals AM plus MB. So that is the segment addition postulate. And then the only difference from the second to the third step is that instead of this being MB, it's now AM. Well, how do we just replace something like that? From this first step, they told me that MB equals AM, so I can just replace it or substitute it. So that's the substitution property of equality. And last but not least, they just combined these like terms, AM plus AM, and they got 2AM, so they call that the distributive property.